Hi everyone, this is Amir here with another question of Craig's mechanics of materials or solid mechanics. Okay, let's start solving this question. In this question, you can see a rigid beam AC, which is supported by a cable BD, and a load W is suspended from this rigid beam at point C. The length of the beam is given to us, which is 3 meters. The length of this cable is also given to us, which is 2.5 meters. The diameter of the cable is 25 millimeters. The yielding stress of the cable is 250 megapascal, and the modulus of elasticity of it is 200 gigapascal. The maximum displacement at this point C is 10 millimeters. The factor of safety with respect to yielding is 3.3, and with respect to displacement is 3. And now the question is asking us to determine the allowable weight that can be suspended from this point C. Okay, let's draw the beam first. So this is our rigid beam. This is point A. This is point B, and this is point C. We have a load FBD here. We have W, we have AY, and we have AX at point A. And now, in order to determine this FBD, we're going to write the equation of equilibrium for moments around point A, and then we can determine the value of FBD based on W. So if we write sigma MA is equal to 0 in this direction, we can say FBD multiplied by this distance, which is 1.5 minus W multiplied by this distance, which is 3 meters, is equal to 0. And this will give us an FBD equal to 2W. Now the factor of safety with respect to yielding stress is given to us, which is 3.3. And we know this factor of safety is actually sigma of yielding divided by sigma of BD. And for this sigma Y, we have 250 megapascal. And this was equal to 3.3. So sigma BD will be equal to 250 megapascal divided by 3.3, and we can also write that sigma BD is FBD divided by ABD. So FBD was 2W and ABD is pi divided by 4. D of BD was 25 millimeters, 0.25 meters in the power of 2. Using this and this, you can say 2W divided by pi over 4, 0.025 in the power of 2 is equal to 250 divided by 3.3, and since we used megapascal, this is 10 in the power of 6 Pascal. So the only unknown value here is W, and this will give us a W approximately equal to 18.594 kilonewton. So this will be the maximum load W that can be suspended from point C so that the axial stress in this cable BD doesn't exceed 250 megapascal with a factor of safety of 3.3. Now we had another condition, which was the maximum downward movement of this point C shouldn't exceed 10 millimeters with a factor of safety of 3. Okay, for the second condition, this is point A. Since this is a rigid beam, there won't be any deflection when we apply a load in it, and it can only rotate around this point A. So after applying a load here, it will just rotate like this way. This will be our delta C, and this will be our delta B. And using the trigonometry equations in this triangle, we can say that this length divided by this length is equal to this delta B divided by delta C. So we know this is 1.5 meter, and we know the whole length is 3 meters, is equal to delta B divided by delta C. So delta B is half of delta C. Delta C is equal to delta C maximum, which is 10 millimeters, divided by a factor of safety with respect to displacement. And this was 3, so it's 0.01 meter divided by 3. So delta B will be half of this value, which is 0.005 meters divided by 3. And we also know that we can relate this displacement to the load applied to the cable. So this is actually the displacement of this cable that was hanging there. So the initial length was this, and then after applying this load, the length was increased this amount. So this is the final length. So delta B is FBD. This is a tensile load in the cable. LBD, which is 2.5 meters. A, which is the cross-sectional area of the cable. And E, this is the modulus of elasticity, which was 200 gigapascal. So FBD is 2W. LBD is 2.5 meters. ABD is pi divided by 4, 0.025 in the power of 2 multiplied by 210 in the power of 9 Pascal. And this delta BD is 0.005 divided by 3. So the only unknown value here is W, and after doing the calculations, W would be approximately equal to 82.725 kilonewton. So this was for the first condition, and this is for the second condition. So this one says that if we suspend a load greater than this value from point C, the maximum displacement of point C will exceed 10 millimeters with a factor of safety of 3. Okay, so now we determine two W's, and we have to decide which one to use as the answer of the question. what's the maximum load that can be suspended from this point. Say you're driving in a road and the maximum allowable speed in the roads are 50 kilometers per hour. And then in a specific area in that town, say there's a school zone, the maximum allowable speed is 30 kilometers per hour. So we have two values for the maximum speed. One is 30, one is 50. So we have to drive with the minimum, which is 30 kilometers per hour. And this is kind of the similar situation. So the answer of the question would be 18.59 kilonewtons. So if we apply this load, this condition would automatically be fulfilled. That's it. Thanks for watching this video. Again, if you haven't subscribed to the channel, please subscribe. That's a great way to support us. You can subscribe by clicking on this red button. And if you like this video, please press the like button. And finally, if you have any feedback or suggestions or comments, feel free to write for us in the comment section. Thanks, and see you in the next video.